Hubble's law, question 1. The graph below shows data on recession speed against distance from Earth for a number of galaxies. Recession speed here on the y-axis, making note that it is times 10 to the 4 kilometers per second. Distance from Earth on the x-axis given in megaparsecs. Part A, use the graph to find a value for the Hubble constant in kilometers per second per megaparsec. Now this is in kilometers per second, not forgetting the times 10 to the 4, the x-axis in megaparsecs, so we should be okay with these units with no conversions needed. The datasheet tells us that recession speed is equal to the Hubble constant times distance of separation, so rearranging, Hubble constant is equal to recession speed over distance, which is just the gradient of this line, because this gives our recession speed over our distance. So change in y divided by change in x, or the gradient, is going to give us the Hubble constant. Putting lines on to find this out, our change in x then will be 1200, the change in y about 7.8. So we can put the numbers in. Gradient is 7.8, not forgetting the times 10 to the 4, divided by change in x of 1200 megaparsecs, giving a Hubble constant of 65 kilometers per second per megaparsec. Part B. A galaxy is observed with a recession speed of 23,000 kilometers per second. Calculate its distance from Earth in megaparsecs. Well, again we need the Hubble law formula, V equals hd, this time rearranging for d equal to recession speed over the Hubble constant. The recession speed, 23,000, we were given here in kilometers per second, and our value of the Hubble constant was 65 kilometers per second per megaparsec, giving a distance to the galaxy of 354 megaparsecs. Part C. Given that the age of the universe can be estimated as 1 over the Hubble constant, use your value for Hubble's constant to calculate the age of the universe in years. And we're given details that 1 parsec is equal to 3.3 light years, a light year being 9.5 times 10 to the 15 meters, and 1 year being 3.2 times 10 to the 7 seconds. So we know that the time is equal to 1 over our Hubble constant of 65 kilometers per second per megaparsec. Now this, in terms of the units, the negative power means it's on the wrong side of the line. So this is effectively 65 kilometers with seconds on the top, and this megaparsec should be on the top. So what I've done here is just placed the units in their correct places, so we have the megaparsecs and the seconds on the top, and the kilometers on the bottom. Now for some conversions. Well, to go from kilometers to meters, as we need to do, you multiply by 1,000. In going from seconds to years, we need to divide by 3.2 times 10 to the 7. And to go from megaparsecs to meters, we need to multiply by 10 to the 6 to deal with the mega part, then by 3.3 to get parsecs into light years, then by 9.5 times 10 to the 15 to get light years into meters. So now, if we add all these conversions, we get that the time, or the age of the universe, is equal to 10 to the 6 times 3.3 times 9.5 times 10 to the 15 over 3.2 times 10 to the 7 times 65,000, which gives us an age of 1.5 times 10 to the 10 years. Finally, part D. The recession speed will have been found by comparing spectral lines from the galaxy with spectral lines from the same elements on Earth. Explain why the spectral lines will differ and how they are used to calculate the recession speed. Well, there are 4 marks for this question, but it is in 2 parts. Why the lines will differ and how they're used to calculate recession speed. So it's probably a couple of marks for each part. Well, why they differ is they will be redshifted, or they'll have gone to longer wavelengths or lower frequencies, and this is due to Doppler shift. Use technical terms whenever you can. How the calculation is made, well, that's using this equation, which is on the data sheet, that the change in frequency over the actual frequency is equal to the change in wavelength over the actual wavelength, which is equal to the recession speed over the speed of light. And this applies as long as the recession speed is much less than the speed of light.